I'm Moya Crawford, that I'm managing director of two companies, Deep Tech in the UK and Deep Tech AS in Norway. My background, I've had a lifetime in marine salvage, and I take innovation into numerous sectors, including oil and gas.
Hi. Hi, my name is Mark Lawrence. I'm currently with Waves Group, normally based in London. Speaking to you today from the west coast of Scotland. I'm had a long-standing career in maritime. Started life as a commercial diver. I founded a company called ADUS, which specialised in survey subsea, both for historical shipwrecks, but also more modern casualty sites, which is what I'm engaged with day to day these days. So that's me. I'll keep it short.
Okay, Joel, are you there? Need to unmute yourself, I expect.
Yes, hello, I'm there. Hello, nice to meet you all. My name's Joel Mills. I'm the CEO of Offshore Simulator Centre and CEO of a company called Augment City. I'm based in Ålesund, which is a small town on the west coast of Norway. You can obviously hear from my accent, I'm not truly Norwegian, but I've been becoming more and more Norwegian over the last 15 years. My background is in industrial design, and I also am co-chair for a United Nations work group on sustainability, artificial intelligence, and machine learning. And today I'm going to talk to you about simulation, which is where my real passion and what we're working with majority of the time. But I'll hand back to Moya to get things going. Thank you very much.
Thanks, Joel.
Sorry, just going back to the beginning, catching that up on right, there we go, that's got me. If everybody can see the screen. Just going back, so today's salvage and decommissioning, and what I've done with it is that I've included underwater demolition, cargo recovery and wreck removal, because that salvage is at one end of the spectrum, especially salvage on no cure, no pay. Decommissioning in the oil and gas sector in particular is absolutely other. So instead of just taking into some very sort of niche concepts, that we are going to discuss how technology and looking forward, digital technology in particular, augments what is a very, very ancient occupation or undertaking of salvage. So I've just shown you here on the map where each of us are. That I'm in Scotland. Wave Groups works predominantly out of London, but is global. And Ålesund has just moved slightly into the north east Atlantic, but it shows you where Ålesund is in Norway. All of us that you'll see today work together, collaborate on various projects. But really what we want to do is show how salvage as an undertaking with its basic principles and these are that it's of success, danger, and being a subject of salvage, that really makes salvage, it's an undertaking. It's like science. It's not just an activity. It's an undertaking. So we're going to take you back. This is a wreck called the Torrey Canyon. For those of you that are a little older in the tooth like me, this happened when I was a child. But the Torrey Canyon, as a tanker going on the Scillies, in 1967, that transformed shipping and salvage. It transformed salvage because Weissmuller, the company, the family company that responded to it, that it responded on no cure, no pay. And when the British government, when the RAF, after significant tries, bombed this wreck, they actually bombed the principle of salvage, in my opinion. But it's these wrecks, they're each taken on a case-by-case basis, that you can see how salvage changes over the years and is changing now. And so in showing some of the past, we also want to show you the future. The Deepwater Horizon, again, is another wreck. Many of you will remember that from 2010, that she became a wreck, that this is her being responded to as a casualty. And she was responded to under the commercial agreement of no cure, no pay. And she is treated here as a ship. So you immediately see for us that the oil and gas sector doesn't sit on one side and that the maritime sector on another. We merge them together, and so the techniques that you'll see on the surface and beneath the surface are merged as well. My particular form of salvage has been cargo recovery. We've been quite a strange company. Our vessel, that when we had Redeemer, when we had our own vessel, she is the vessel on the right. And with this tiny vessel, we went on to, we tripled the world's depth record for commercial cargo recovery. That was 1,250 meters of water. That was probably staggering enough, but it was 45 miles off southwest of Cape Finisterre in the Atlantic. And then we went on to work a wreck, find it first, the wreck of the SS Persia. So for me, that finding of a wreck was always very, very difficult. That the Persia had 3 positions of loss. She was sunk in 1915. So we first had to find our wreck, and from the positions we were given, that was anything that she may have lain in 2,000 to 4,000 meters of water. She happened to lie in just under 3,000 meters, 2,800 meters. And you can see us finding her on the left-hand side of the picture. And that was the last job that our vessel Redeemer did. So this is us, when I talk about innovation, this is us setting up on the left-hand side of the picture on the wreck of the SS Persia, that this is equipment that has been designed and built completely in-house, put on board that a vessel, DP1 ship. And you can see here on the right-hand side of the picture that this is us trialing, this is us getting our equipment to work on site. This winder system was never used at all before anywhere in the world. We built it, we got it working on the vessel. This is the use of high modulus polyethylene as a tension member. This is now 20 years ahead of still where the oil and gas sector is. And what you can see with the equipment here is some winding power and signals around that high modulus polyethylene, which is weightless in water, so that we can operate the sort of industrial equipment that you see on the left-hand side of the picture. That grab has 200 tons closing force. And in order to reach the bullion room of the SS Persia, we had to cut down through 5 deck levels, remove hundreds of tons of overburden to get to the bullion room, which it was built in feet, so 20 feet across, 8 feet deep and 4 feet wide. So I just go on to the, you see here, so you'll see the Persia underwater. Here, this is the first view of the Persia that anybody had seen after 85 years. And 2, I bring your attention to the fact that we can only see one part of it at a time. So not only was this for us that both a very, this is in terms of technology, to be able to find this wreck, to get our equipment to work from it, to even at this time, this is in the beginning of the 2000s, to get the video images that we've got, we had to change almost overnight to single mode fiber optics. So you can see that how having better information would completely have changed how we would have worked. And so this is why I wanted to bring these 3 talks together. I'll show you on the left-hand side, just put a very quick video, which shows, just to show how technologies meet together, that as a company, as a salvage company, like many others who work absolutely on first principles, and our technologies were taken and that we became the contractor for a £10 million that design and build contract for Lightwell Intervention down to 3,000 meters of water, which was the leading edge of oil and gas. So I really wanted to leave you and pass you on to Mark, showing that from Salvage on basic principles, on very, very hard contractual agreements, it's absolutely married to innovation. But I would have liked to have the technologies that you're going to see next, and it would have revolutionized our work on the Persia. And I'm just going to stop sharing now. Mark.
Hi, can everyone hear me there? Can you hear me, Moya? Great, okay. And hopefully I'm sharing screens as well. Can you give me a thumbs up that that's working? Okay, so just carrying on from where Moya left off, what I wanted to show you today was some sort of a case study, if you like, of a number of wrecks. But I'm going to start with a wreck off the east coast of the UK called the Moya Crawford. And this is a project that we did for the UK MOD last year. And it was a so-called legacy wreck. So it was sunk in the Second War, containing significant quantities of oil, or so we thought, and therefore was a pollution threat. So what I want to do in this presentation, I'm actually running a GIS package at the moment, so I'll just pause it. Was to show you some of the techniques we're using for acquisition of three-dimensional data, and more importantly, how we're using that data for intervention strategy, for our ability to increase our situational awareness, improve communication and collaboration. So I'll just add in an image here, hopefully, of the Moya Crawford. So what we're looking at here is the wreck of the Moya Crawford, as I said, lying on its port side in about 50-60 meters of water. And the wreck is, as I say, a legacy wreck, which sank in 1941 and thought to contain significant quantities of oil, because when she sank, she was more or less intact, having suffered a torpedo strike to the port side from a fast torpedo boat. But she did sink with significant quantities of oil on board at the time, so it was always a worry that there was significant quantities of oil remaining on board, and therefore a pollution threat. If I then swim round to the other side of the wreck, hopefully you're getting this. I also just wanted to make a couple of points that about this sort of data. We all, as humans, think in three dimensions, and that's no surprise, as we are living in a three-dimensional world. But hopefully, you can see immediately that without me really describing too much about what how the wreck is and how it's lying on the seabed, the use of this three-dimensional data already gives you that sort of level of understanding. I also wanted to make the point that in our profession, still today, we're still making use of two-dimensional information in terms of static reports and the like. But it's really only when we get into the use of three-dimensional data that we can really begin to add some value, I think, in terms of our level of understanding. And in this particular case, without the three-dimensional data, we couldn't have planned the sampling regime that we undertook to find out if there was significant oil remaining on board. The other point I wanted to make is one about certainty and the value of this sort of data, especially at the beginning of projects, where we can essentially remove the water and have a good look around this wreck and understand it in a way not possible by any other means. And that really does increase the certainty of outcome, because we can understand exactly what we're dealing with in terms of situational awareness. So in this particular case, the level of resolution was sufficient using multi-beam sonar. So here, what you're looking at is actually a point cloud data set from acquired using remotely operated vehicles, but a multi-beam sonar system. And because of the resolution of the data, we were able to accurately overlay GA plans on top of that data set. And that effectively has allowed us to position the areas of interest. I'm just going to pause that there. So in our case, we were interested in the oil tanks, and this is where the oil was stored during the when she was afloat. She was a freighting tanker, as I've said. So here we're looking at holds number 4, 5, 6, and 7, and we were able then to undertake a sampling regime. And if I just pop this image on here, we undertook a sampling regime using a neutron backscatter device handled by the ROV. But it was only because we had the high resolution data set and the GA plans that we were able to accurately position that, backscatter device. So I'm going to just cut that a little bit short now, because I know we're pressed for time with Joel, because even though we didn't find oil on this particular wreck using this sampling regime, had we found oil, we would have then been into a whole different sort of situation with trying to understand cost and implications for getting that oil out. And this is where it would have been really useful to have all this data within Joel's simulation package to understand you know, the implications of all the different types of operations that would be needed, and trying to cost those in a simulation package. So I'm going to just stop sharing there and hand over to Joel briefly, and then I'll be back to show more examples of this sort of data.
Okay, hello, can you hear me? And hopefully you can also see the screen I'm sharing. So I'm going to talk to you now about simulation, which is obviously software, but actually it's not about software at all. It's about people, and it's about how people can work together and how we can make better decisions by using different software solutions. So first of all, I'm just going to show you where I am. I'm in the pretty town of Ålesund in Norway. Unfortunately, it's not quite as nice as that view out there, the view you see there today, but it's not so bad. I also show you some of our simulators. We've got these very large simulators where we have, say, the big dome there's got 35 projectors in it, so you walk into it and you're completely immersed into a solution. And the point of this is basically trying to take people into a situation where we can have a better understanding, and we can go beyond reality using simulation to really understand how things can be done and how we can make things possible which wouldn't have been possible in the past. And we've been doing this for a long time in the oil and gas industry, and now we're looking to take this and we're using these technologies in other industries also. So again, some pictures of the simulators, but what I want to start off with is Mark has been showing you some really good quality data acquisition. So he's been showing you some really good point clouds of different wrecks, and he's going to show you more about that. And the one he showed you now was the Warmatar wreck. Now, technology has been progressing a huge amount. So what we were able to do is Mark was able to give us that point cloud. We were able to use some software, which within under an hour, we were able to convert that point cloud into a solid mesh. Now that means from a point cloud, which is basically, you can imagine like a ghost, which shows you where everything is, but it's just a visual, we can turn it into a mesh, which takes it into a solid object, which then we can start to look at and do things with. So we're able to put this in the location we needed to put it in, directly on the seabed. We were able to put the vessel into place, and then we're able to overlay all of the different bits of equipment we want. We're then able to use our product, which is our sandbox product, which is our product we've developed for working with this and building up simulation in very, very high speed. It's basically like building Lego blocks, but you can build in things. So in this example here, we've thrown in an offshore vessel, and then we're going to show how we're going to do what Mark talked about and understand how we go down and do some observation on that vessel. So we pick out a large system with an ROV on it, and we place that on board this vessel in the right location, and we're able to basically just move it around exactly as I said if it was a Lego piece, and we're placing it into place. But the minute we place it into place and it goes from that ghost view to a solid view, then all of the physics is correct. So the forces now, which are coming from the waves to the vessel, are correct. And now what we're going to do is we're going to show some situations of understanding how this vessel would perform in different wave conditions and different directions of current and wave heights to be able to do that operation of that inspection with an ROV. So we can quickly, using the simulation, understand the possibilities of what can be possible in one place or another place, and what sort of vessel you need to do that. So here we're showing the waves going up, and actually we put the waves up to a much too high height here in this example here, and we put them 90 degrees to the vessel, so you start to get a real roll of the vessel, and suddenly you see that ROV is swinging around so much that it's actually bashing into the side of the vessel. Now that's not a condition you would ever want to launch that ROV in, but we're just showing you how we can control all of the attributes, and this isn't just an animation, this is all based on real physics. So we have got over 100 different inputs into the waves here, which then are giving the forces to the vessel, and the hydrodynamics are calculated there, and then they're feeding the forces through all the systems to the launch and recovery system for the ROV. But the wonderful thing with simulation is we can do things in simulation which aren't possible in real life. So we can do what we call augmented simulation, where we are able to change things. So we can turn the water off and we can see exactly what is going on. Now, this is a view you would never be able to have in real life, but in the simulation, you can do this to really understand what's going on. We can also go down to the perspective level of a human, and we can place somebody in, and we can even take control of that person, so we can understand exactly how this is going to be from the human's perspective, which is a very important thing. So we're able to walk around and take control of that person and step into his shoes, if you want to say it like that way, and we can look around, and this deck of a vessel is completely empty, but we can actually go in and we can assign ourselves to that person there, and we can look at things directly from that perspective and understand exactly how an operation is going to be performed. So we're able to look at things from the detail of the people involved. We're able to take control of any of the objects, so we can jump to the vessel bridge, we can jump to the ROV cameras, and we can understand things from all of the different perspectives, but we can also take this world view where we're able to fly around and see things from a different direction. So we've lowered the ROV through the splash zone. I've actually skipped a bit here because I didn't want you guys to wait while we did all the lowering. So we start lowering the ROV down, but actually in this case here, we suddenly then jump to the point where the ROV is down by the vessel, because I wanted to keep the video short enough to show what's going on. So now we're the ROV, and we've actually coming through the water, and you can see that we're just using our spotlights to pick out just the area of the wreck we're looking at, and we're able to approach and go into that wreck. We're also able to, as you saw before, go in and change the visibility of the water so we can get a better idea of what's going on. So we can just go into our settings here, and we can just make that water a little bit more transparent, so we're able to understand what's going on and really get a better view of the full situation, better than you'd even have in real life in this case. But it gives you an idea to understand what's going on. Now, as Mark mentioned to you before, one of the objectives here in the first place was to place this scatter device, this ROV, was to go up to the side of this vessel, place this scatter device on the side of the vessel and take a reading to see if there was oil in these tanks or not. And then if there was oil, it would have to be about how it was pumped out. So that was showing that. Here we're showing how in the simulator we can have all sorts of data, and here we're showing how we don't just do digital twins of offshore, but we do digital twins of a whole world. So we've got cities, and we've got a number of different cities. We do work for the offshore fish farms. We obviously do a lot of work for oil and gas. If it's installation, decommissioning, or just operation, we're able to look through all of that stuff, and we're very used to working in building very complex digital twins of subsea. We also work with the renewables industry, so we're working a lot with the wind industry, and here we're not just looking at the installation, but we're also looking and understanding how things are over time. So we're able to, again, augment data. So in this case, you're looking at wind turbines, and we're able to see the efficiencies of the wind turbines over time and really understand all of the different details of what's going on there, so we can have a really good feedback. So we're able to link this in to live data and really follow things which are going on live. So if we're talking about a wreck removal, we'd be able to take in the real weather conditions for exactly that point and put in the wave conditions, so we could follow the operation live and maybe be remote support to help with things. But the reason we've actually picked Bergen here is because we wanted to use this as an example, because of just off the coast of Bergen, we're just flying past the coastal steamer here, but just off the coast of Bergen, there is actually a sunken submarine, which is a project which they need to look at how they will do, or if they should at any point do a removal. Now, this isn't actually the submarine which is off Bergen, this is the submarine which is off the very north of Norway, but we just put this in as an example. But this is a classic example where we've brought in a 3D model, we've converted it to a solid model we can work with, and then we could quickly use the simulator and live with Lego, build up all the pieces to understand of how or if we should do any sort of removal and how we could go about doing that. So I really wanted to finish off on the on the submarine there to basically just give us an idea and a taste of what could be possible. Now, the whole point of simulation, as I said at the beginning, is linking humans to machines. And the reason for doing that is basically breaking down these barriers. It's being able to understand and do things in a way which isn't possible today in other solutions. It's also to look about new technologies. The biggest blocker for new technologies is not knowing how they're going to work and the time scale it takes. If you're going to make a real prototype and test it out in real life, if you're lucky, you're able to do that in a year. In a simulator, you can do that in 10 minutes. You can go through 100 generations of a prototype in a simulator in a few days, which would take years and years to do in real life. But the biggest driver, with all these things, is obviously time and cost. And in this situation, we find that within the work we've been doing in the past, we are saving huge amounts of time and cost because we're able to understand the best possible methods to do things. And obviously, the cost of doing something in a simulator compared with the cost of doing something offshore are not even comparable. So we can test things out very quickly in a simulator, find better solutions, and really streamline those processes. So that was really all I wanted to say with my little quick taster of what we're working with. I'm going to hand you back over to Mark, who's going to talk a little bit more about some other wrecks and to give you some more feedback. I'm afraid I have to run off to a new meeting. I'm a bit double booked today, but I really wanted to come and talk a little about this. But if you've got questions, please put them in the chat group afterwards, and I've been promised they will be forwarded to me afterwards. So thank you very much.
Okay, thanks, Joel. Steve here. There are a couple down there. We'll forward those to you later if you're not able to hang around there. There's one about, are you able to do full cruise simulations to train team dynamics as well? Is one question from Paul Ryan. And there's another one, what software are you using to simulate the operation? You know, do the load cases, the crane loads, the loads relative to vessel motion be extracted from the simulation? You muted, yeah. You're on mute, Joel.
Oh, there we go. Sorry, I think it needed me to you to unmute me, but thank you very much. Yes, I'll quickly try and answer those before I run off. So yes, we are able to do full crew simulations and train everybody. We're even able to do situations where we link together different simulation sites across the world. So we can have a simulator in Scotland, a simulator in Norway, and a simulator in Australia, and we can connect those together, and we can have people within those different simulation sites working together as long as they're all running the same software. So yes, we do full crew trainings, and actually we work with we have Equinor here every week doing different crew type scenario trainings. What software are we using? It's our own software, and it's called our Fathom platform. But if you want to find out more detail about it, just send me an email to OSC. So it's jam@osc.no. But it's our own software we're doing. And in that, yes, we do have all of the loads and all of the details, and anything can be extracted or added into the simulation. So we can actually graph out any details you'd want to know from the simulator, or you can take it directly out as a CSV file if you want to know the details of what's going on with that. I think it is a Russian submarine, but Mark will tell you much more about that. And yes, we have simulated sonar views because we have full ROV simulators with all of the different parts for ROVs. So I rushed through some of your questions very quickly there because I know I'm a bit late for the next meeting, but if there are more questions, please do send me an email or get in touch. And thank you very much for listening, and back over to you, Mark.
Mark, you'll need to unmute yourself again. There you go.
Ah, that's it. You have me muted there. Yeah, just to add, that's the submarine in the view there. That was, in fact, the B159, which is located off the Kola Peninsula near Kildin Island, and was a November class nuclear submarine, which sank under tow in 2004. We did a survey of that some years ago now, 2008, but it still remains on the seabed and is there's a planned well, lots of chat about the recovery of that sort of stuff. I don't know, Moya, whether you want to say anything else before I launch back into a few more slides and examples of data sets that we've used. I think perhaps I'll just continue. Oh, okay, it's giving me the thumbs up. Okay, so hopefully I'm sharing screens again, and I'll just stop the video, increase the bandwidth a bit. So I'm just continuing with another example of how we're using 3D data to inform decision making, and really that's the point of all these images that you're seeing. We're not just showing pretty pictures. The data really does have a value, and 3D data has a value too. And the project I'm just looking at here was an instance, a wreck that we worked on some years ago, where in the Singapore Strait, a vessel called the Stolt Commitment was coming out of Singapore, collided with a vessel called the Thurko Cloud coming out of Batam, and the Thurko Cloud ended up in two sections on the sea floor, which hopefully you can see on the screen now. The stern section is to the bottom right, and the bow section is to the top right, about 1,600 meters apart. We undertook a full high-res multi-beam survey using ROVs. And as you can see, you've got an immediate understanding of the situation that you just couldn't get in any other way. And as I said before, we're running this in a GIS, in a geospatial environment. So immediately I'm able to undertake measurements, for example. So I'm just taking a few measurements here. So immediately we've got an understanding of this thing that we just couldn't get in any other way. And that really does help to inform all subsequent operations. And in this case, the full wreck removal. So that's the bow section. We also were able to place in context ROV footage, and we can see here that there's an ROV video image that is being tracked along. I'll just restart that route. You can see how we're using the nav data from the ROV to put into context the ROV footage. So the level of understanding about what we're dealing with is much higher in that instance. If I just whiz myself over to the stern section, this is about 1,600 meters away in about 50 meters of water. And again, this full multi-beam survey was done to inform the wreck removal process, and in the first instance, the oil removal process. And what we've done here is we've overlaid both GA plans and tank plans to get access and to understand geospatially where the bunkers were and what the task list would be in terms of understanding time and cost to remove all the debris and undertake an oil removal operation. So the data was really quite valuable for that quantitative risk analysis process, if you like, to feed all this data in. Without that level of information, we really be sort of flying blind in terms of the planning process. This is all the cargo, by the way, that you can see spilt around the wreck. That's all railway track that's come from the bow, largely from the bow end, and spilled over onto the stern section. See all the details basically on the transom as well, the damage as the stern hit the sea floor. So a lot of sort of forensic evidence in here as well that was useful in the understanding of what happened when too in this particular case. I'm also gonna just fly now to another example, but this is above the water, because I wanted to make the point that we're not just dealing with stuff subsea these days in terms of data collection. I'm just going to fly off to another example of a project that we did in just completed this year. Where are we? Which is up in the Arctic. So this is a fishing vessel that went aground in the Arctic. We did multi-beam bathymetry. So again, back to this point about situational awareness, what can you do to, especially in a challenging situation like this, understand the nature of the seabed next to this casualty, but also the casualty itself, which in this case was a grounding, and the vessel was up above water on the rocks and ice. So what we did here was to fly a drone only for about sorry, I'll try and keep it still, 40 minutes or so. And then using that drone footage, we were able to create a three-dimensional model that you can see here. Just turn off the GA plans. So this model was created purely using photogrammetry from the drone footage. And we ended up there with a metrical model. Again, as you saw before, we were able to measure distances and do cross sections and get an understanding that we just couldn't get in any other way. And I said as well about the challenging conditions. Here, for example, we had issues with polar bears. So again, just being able to look at the casualty in this way was very instrumental in the planning and the eventual sort of removal. This vessel, by the way, is now completely gone, and that was completed just earlier this year by Schmidt. So that's a couple of examples. I know time is pressing on, so maybe I'll hand back to Moya, unless there's anything else you wanted me to show, Moya. I think I'll hand back to Moya.
That's fine. Okay. that should, hopefully that's me speaking again now. I just really wanted to conclude. I'll just go back to sharing screens, and just let me bring that up from where we are. Hopefully, let's see. Hopefully that is up and people can see that. And if I can do from the current slide. Okay. Right, you can see that the Havila Phoenix, it's not that she's just the only ship.
Excuse me, Moya, Steve here. We're not seeing your screen at the moment.
Oh, sorry.
Okay.
Sorry. I thought I'd done it. My apologies. Let's see. Right, I don't want to. I don't think I'm managing to. Is that it, Steve? Can you see it now? Yes.
Yeah, it's started to share now.
Sorry, my apologies for that. From current slide. Okay, we saw the Havila Phoenix. I was going to say she's not the only ship, but she's a very popular one. I just really wanted to try and pull matters together. There was a question I saw earlier about saying, can you take the data off the images? This was a piece of work here that put what we'd learned regarding using synthetic filament rope into products which were taken into the oil and gas sector. And that Deep Tech was the first company to bring out its technology in synthetic filament rope cranes anywhere in the world. And I say to people that wasn't because we were the best engineers in the world, it's because of our salvage background. And that we were able to use the MVGL standard, first principles based standard. So this again is the point I'm wanting to make, is that salvage doesn't sit on its own, and its ability to innovate and also take in new technologies really expands the frontier for innovation. So this contract that was undertaken in Singapore, you can see here too that this is us. This is the first time I used the offshore OSC simulator in Norway. I think this is about 5 years ago now. And what it showed to us, that it demonstrated that it wasn't the lifting system, it wasn't the rope that was the limiting factor, it was actually the vessel itself. So it's so important to have this holistic picture. And what the simulation allows us to do is have a systems approach. That the question was asked about data. This is data sets that we've taken off the out of the simulation so that we look at the load. And this allows us to plan. And as Joel said earlier, that the ability to look at multiple scenarios is absolutely essential. And so it's getting the right data in. So just going here, it takes us back to, again, the concept of actually working equally in what people think of as the oil and gas sector. This is obviously a mobile offshore drilling unit that you can see here, that we're looking at the riser motion. And again, although we're looking at winches, that we can see the whole system working. So one of the things I really wanted to leave you with is that ability not only to get actual on-site data underwater, get it in the simulator, take the COA, take the measurements, but we can take that between people putting their technologies together, we can get a whole systems approach. So this was just the work there. So just going on to finally going on to the decommissioning focus, that you'll see in the section here that it actually says that salvage synergies? Well, there are numerous in decommissioning, and that this is very, very important to take forward, driving efficiency and cost reduction. But I have to say, it's not the technologies and even the software that it's important to address. It's the philosophies and the commercial philosophies as well. So I'm afraid, chaps, that salvage comes as a complete package. If you want to bring the innovations that we have, then actually it's also thinking about the way things work. And we all, as it says, it infers with this small cartoon, is that we all work in the laws of nature. And as I say, often to people, the last time we looked, they were the same in oil and gas as they were in salvage and wreck removal and cargo removal. So that going forward, this is just really a taster. What we're all planning to do in the new year is to put this actually in VR. So what we'd like to do with what people have seen today, if they're interested, is in the new year, show what we're doing in VR. And our aim as companies are working together is to do what we've shown you essentially in wreck removal and bring forward Mark's work and actually do that in real time. In real time for salvage. And so that will be really the acid test of bringing the philosophy and the technologies together. But as Joel said, it's all about people. So that's me. I'll stop sharing and go back to Steve.